Hey everyone, welcome back. This is the walkthrough video for the percent composition of a hydrate lab. So our objective for this lab is to determine the percent composition of water in a hydrate. So you might be asking yourself, well, what is a hydrate? And the background information will tell you. It is a compound that contains a set number of water molecules. So for example, we have copper sulfate with 5 different water molecules around it. And they form, this crystal. The water can be evaporated away, forming what we call an anhydrate, the compound without the water. Now in this lab, we're going to be working with copper 2 sulfate pentahydrate. So that's our copper sulfate with the 5 water molecules. Now this lab is broken up into a few parts. Part 1 is all mathematical stuff, and the calculations that we do will help us with part 2. So question 1 is the molar mass of just one water molecule. Next one is, what does penta mean, or how many water molecules do we have in pentahydrate? Next question is the molar mass of 5 waters. So if you know the mass of 1, what's the mass of 5? Next is the molar mass of just copper sulfate, or copper 2 sulfate rather. And again, round all numbers to the nearest tenth. That is 1 decimal point. This question right here is calculate the molar mass of the hydrate. That is this entire thing. So as at this point, we know copper sulfate. We know what 5 water molecules are, so we can just add those two together. Now, the last one says determine the mass of 0.004 moles of the hydrate. So all you have to do is take this answer and multiply it by 0.004 moles. That will give us the amount of hydrate that we'll need in part 2. Spoiler alert, it is 1 gram. Okay, so at this point, this is when we jump into actual lab experimentation. And at this point, you must be wearing goggles. So whatever you're doing at this point, stop, put them on. Now, we are using hot plates in this lab, so your station may be hot. Be careful. So moving on to part 2, this is our hands-on part. The first step is to plug in your hot plate, make sure it turns on so it heats up and it's ready for the time when we need it. So each station you'll find this green bin full of all the supplies you may need, including this. So your first step is to take out your scale, open it up, turn it on. Make sure it says 0. If it doesn't, you can hit the button that says tare. You're going to take your empty crucible and you're going to weigh it. And then whatever it says, you're going to write down on your data table where it says empty crucible rather. Now in part 1, you are to calculate how much of this blue crystal that you would need. This is our copper sulfate hydrate. So we're going to weigh out 1 gram. Okay, so we've added about 1 gram of our blue hydrate. Again, it's not that much. So I'm going to weigh it again with the hydrate in it. We're going to write that down. Now you'll be able to find the exact amount of hydrate that you added by subtracting the combined crucible with the hydrate and the crucible alone, giving you row C in your data table. Now what you're going to do is heat this up. Now at this point, your hot plate is going to be pretty warm. So we'll close that, turn it off, cap this. Again, we only need a little bit. We're going to take our hot plate and very carefully place our hydrate on the hot plate. Now it should take about 5 minutes. Do not heat this up for more than 5 minutes. Okay, so now you've been able to see a color change from that very bright blue, again, which is this, to more of a white color. Now what we're going to do is take this off the hot plate, but it is hot, so we have to do it very carefully. And we're going to, before we even take it off, get this ready. This is our, out of the way, this is our cooling tray. We're going to put that off to the side, and with your orange glove on, take the crucible tongs, and you can either, if you're more comfortable, just grabbing your crucible and putting it down. if you are more comfortable, again, with your gloves on, picking it up and moving it off to the side, either way. So we're gonna let that cool for about 5 minutes. Once that is cool, and at this point you can turn off your hot plate, unplug it. Once this is there, we're going to let it cool for a few minutes so it is touchable. Do not move it, let it cool. Do some calculations that need to be done on your sheet. Once this cools about 5 minutes, you're going to reopen up your scale, and we're going to take the mass of the cool crucible. Again, at that point, it should be cool enough for you to pick it up. You're going to mass it again, write that down, and then you have all of the data that you need to progress with the rest of the lab. To clean up, all you have to do is take this, dump out the white powder into the garbage can, make sure your heating plate is unplugged, and everything goes back very neatly into your green bin. Part 3, we're going to compare what we did mathematically compared to what we did experimentally. And so for part 1, we're going to calculate the percent composition of water using the chemical formula. So what that entails is calculating the percent water. So this is our part, and this is our whole. So that's for that. And then question number 2, percent composition of water in a hydrate using experimental data. So you're going to need to use the amount of water and the amount of hydrate. Now, in theory, those answers should be the same, but we know errors happen when we do experiments. So your job then is to calculate the percent error in your experiment. Now, these two formulas come from Table T, which is the last page in your reference table. And that is this week's lab. Have fun.